Hello friends, welcome back to the channel. Today in this video we will discuss about the Front and Katafront. So when we all read about the air mass and prawns, but this topic may be new to you, so please listen carefully. And yeah, this is a very important concept actually. So fronts generally form within a baroclinic boundary between cold and warm air mass. The main physical processes for the development of cold fronts is the movement of the cold air against warm air. The warm air ascends along the boundary while the cold air sinks below it. If there is enough humidity, the upward motion leads to condensation and to the development of clouds and precipitation. So basically, start from here the topic. The cold fronts can be divided into two types, ana and kata cold fronts. These types can be described both in terms of classical frontal theory and in terms of conveyor belts. The main feature which separates the different types of cold front is the orientation of the jet relative to the front in the middle and upper levels of the troposphere. In the case of an ana cold front, the jet axis and dry intrusion are parallel to the frontal cloud band and form a well pronounced rear cloud edge. In the case of a kata cold front, the jet axis crosses the frontal cloud band. So, quite difficult to understand, seems like. There are some uncertainties about the structure of ana and kata types. It is not always completely clear whether a cold front is ana or kata type. Even within the same front, ana and kata structures can be observed. In these cases, ana features can be found close to the occlusion point, whereas kata structures prevail in the parts of the front further away. The frontal cloudiness, especially in kata cold front, is often not produced solely by the warm conveyor belt. The rear parts of the cloud band are produced by an upper relative stream originating from the through trough behind the cold front. This moist rising stream can sometimes be followed backwards as far as the area of warm front clouds. Thus, the upper relative stream is added to the schematics describing the conveyor belt model of the ana and kata fronts. There can be parallel or even forward inclined warm conveyor belts. The rearward component of at lower levels is due to the agiostrophic wind within the boundary layer, while the parallel or even forward sloping warm conveyor belt in the middle and upper levels is in accordance with the geostrophic wind relationship. And a cold front. According to the classical theory, the cold air moves rapidly against warm air, creating convergence within the baroclinic zone between the two air masses. Convergence forces the warm, moist air to ascend along the frontal surface. The developing cloud band is inclined rearward with height. The main zone of cloudiness and precipitation is located behind the surface front. An exception is a case with strong upper winds which force the high clouds to extend downstream ahead of the surface front. So this is the picture of ana cold front. So this is on the left hand side we have the cold air mass and on the right hand side we have warm air mass. So when they are colliding, the warm air mass is ascending, right, and it is creating a cloud behind the cold front. Okay, so that's why it is called ana cold front. According to the conveyor belt theory, the frontal cloud band and precipitation are related to an ascending warm conveyor belt which has a rearward component relative to the movement of the front, causing the frontal cloud band and precipitation to appear behind the surface front. Parallel to the warm conveyor belt, there is a dry intrusion. The sharp rear cloud edge of frontal cloudiness marks the transition between the two relative streams. So here is shown the transition. Okay, dry intrusion and upper relative stream. So frontal cloud band. So it is cold and warm air mass. So warm conveyor belt. Now kata cold fronts. According to classical theory, the ascent of warm air is restricted by dry descending air originating from behind the front and consequently dissipating the higher clouds. The main zones of cloudiness and precipitation appear in front of the surface front. So this is the kata cold front image. You can see sinking dry air. Okay, there is a sinking dry air. So according to the conveyor belt theory, the ascending warm conveyor belt is overrun by the dry intrusion. The dry air originates from upper levels of the troposphere or even from the lower levels of the stratosphere and crosses the cold front from behind. The warm conveyor belt acquires a component which is inclined forwards relative to the movement of the cold front. Therefore, frontal clouds and precipitation tend to lie ahead of the surface front. The cloud tops in the area of the dry air stream are relatively low, whereas on the leading edge of this area the cloud tops are higher. This area indicates the so-called upper cold front. The air mass which is advected by the dry intrusion is colder than the air within the warm conveyor belt. The intrusion cools air above and later also ahead of the cold front. Furthermore, the air of the upper relative stream has lower equivalent potential temperature. The result is the development of a conditionally unstable layer close to the leading edge of the frontal cloud band. This can be observed as a transformation of layered clouds into convective ones. So this is cata cold front. So layered clouds from convective ones. There are a lot of similarities between cata cold fronts and split fronts. The main difference is the orientation between the jet and the front. It is generally considered that a cata cold front evolves from an ana cold front. As baroclining disturbances often develop over the Atlantic, the newly developed ana fronts can mainly be found there, whereas older continental fronts are mostly cata type. So here you got another information कि as baroclinic disturbances often develop over the Atlantic, the newly developed ana fronts can mainly be found there, whereas older continental fronts are mostly cata type. Another reason for the spatial differences might be that the lower parts of the front are decelerated due to the friction of the continent, while the upper parts continue with higher speed. So this is the I searched a lot and then I did not get any good material to read, but finally I discovered this website, and here it is written in a structured manner, you can say, but the terms are very difficult. Initially I read this for first time, this whatever it is written, the content. So I will suggest you कि please read it again, and I hope you will get some understanding. मैंने कुछ अंडरस्टैंडिंग ले लिया है, जैसे कि मैंने नोट वगैरह बनाया था. तो आई होप यू विल also able to clear the concept of anafront and catafront. Okay, so basically याद रखना कि it is a two types of cold fronts. Okay, और anafront is a rainy cold front, and जो catafront है वो relatively dry cold front है. ठीक है, और anafront जो है ये एक associated with moisture and clouds, और catafront जो है ये moisture and clouds के साथ नहीं related है, मतलब dry है ना. एंड एना मीन्स ascent, कैटा मीन्स डिसेंट, ये तो आपको पता है. और दी वार्म एंड मॉइस्ट एयर राइजेज ओवर द लोअर लीडिंग एज ऑफ द कोल्ड फ्रंट. तो जो एना फ्रंट जो होता है वहाँ पर वार्म एयर राइज करता है, बट कैटा फ्रंट में क्या होता है, वार्म एयर जनरली सिंक करता है ना. तो ये बात है. और एना फ्रंट में क्या होता है कि क्लाउड्स एंड रेन बिहाइंड द एक्चुअल कोल्ड फ्रंट होता है, बिहाइंड द एक्चुअल कोल्ड फ्रंट होता है. अब इमेज को देखोगे तो भी आप पता चलेगा, देखो बिहाइंड द एक्चुअल कोल्ड फ्रंट हो रहा है. तो ये जो है ना, बिहाइंड द एक्चुअल कोल्ड फ्रंट हो रहा है एना फ्रंट में, जो भी प्रेसिपिटेशन वगैरह. बट हम कैटा फ्रंट में देखेंगे तो यहाँ पर देखो क्या हो रहा है. यहाँ पर देखो थोड़ा फ्रंट से ज़्यादा दूर हो गया ना, कोल्ड फ्रंट से ज़्यादा दूर हो गया. तो ये एक डिफरेंस है कि ये भी बोल सकते हो कि एना फ्रंट जो है वो क्रिएट्स क्लाउड्स एंड रेन बिहाइंड द एक्चुअल कोल्ड फ्रंट इटसेल्फ. मतलब कोल्ड फ्रंट के ऊपर ही बारिश होता है. यहाँ पर देखो कोल्ड फ्रंट के अंदर ही बारिश हो रहा है, बट कैटा फ्रंट जो होगा वहाँ पर कोल्ड फ्रंट के अंदर कोई बारिश नहीं हो रहा है ना. तो ये एक बेसिक डिफरेंस है. वार्म फ्रंट में हो रहा है तब बारिश, कैटा फ्रंट में वार्म फ्रंट में बारिश हो रहा है, और एना फ्रंट में कोल्ड फ्रंट में ही बारिश हो रहा है. तो ये कुछ बेसिक डिफरेंस आप याद रखोगे तो आई होप कि जो बेसिक क्वेश्चंस आपसे पूछे जाएंगे वो आप उसका आंसर आप कर सकते हो. ठीक है, तो ये टॉपिक बेसिकली WB सेट में क्वेश्चंस पूछा गया था. क्वेश्चन तो मैंने नोट नहीं किया, अभी करूँगा तो वो आप देख सकते हो. ठीक है, तो उस क्वेश्चन को सॉल्व करने के दौरान मैंने इस टॉपिक को डिस्कवर किया. थैंक यू फ्रेंड्स.